Hello and welcome to this session. In this session, let's first look at some standard techniques to identify violations of the interface segregation principle. First one is fat interfaces. Fat interfaces mean interfaces with high number of methods. If you recall our I multifunction interface from our introductory session, it had around 6 methods to deal with multifarious functions like printing, scanning, and fax. This is almost always indicative of a violation of the interface segregation principle. The next one is interfaces with low cohesion. Let's again talk in the context of our I multifunction interface. We had methods for fax and photoscan. Now fax and photoscans are two entirely different functions. One deals with transmitting a printed piece of paper over a telephone line, whereas the other deals with digitally capturing the colors in a photograph. In other words, there is low cohesion between the methods in the I multifunction interface. This is another indication that we are breaking the interface segregation principle in all probability. Next one is empty implementations of methods. Again, we saw this in our introductory session where some classes had to leave certain method implementations as blank. Blank implementations of interface methods is almost always a violation of the interface segregation principle. So these are some of the ways you can identify violations of the interface segregation principle. Next, let's explore the relation that this principle has with other solid principles. Let's look at our problem solution page. After we split the interface, we can now say that one interface has one responsibility or a single responsibility. So the iPrint interface has only a single responsibility. That is, it holds print-related method definitions. Similarly, the iScan interface has only a single responsibility of holding scanning-related method definitions. So we are inadvertently following the single responsibility principle. Also, after we segregated the interfaces, we are indirectly following the Liskov substitution principle as well. Because now, in places where we use, for instance, the iPrint interface, we could substitute it with the Canon printer class instead. So as you can see, most of the solid principles are intricately linked to one another. Solid principles complement each other and work together in unison to achieve the common purpose of well-designed software. That's it for this quick session. Let's move on to the next session where we do a live coding demo of the example that we saw in the previous sessions.